is that uh, you can so there's a flip operation. It means you can switch the left and the right pointers as many number of times for as many number of children you want in the tree. So, and you need to find out if a tree can be, if both the trees are same after doing those flip operation any number of times and on any number of nodes. So what we're going to do is we're going to take a look at both the methods over here. One is the recursive method and second is the iterative approach of doing the same thing. So first we're going to talk about the recursive approach. In the recursive approach, we're just going to copy all this thing, and then in the recursive, what we're going to do is we're going to, let me just call it t1 and t2. So if t1 is null and t2 is null, that's a very base case that we have, then we simply return true because both of them are same. But if either of them is not null, if t1 is null or t2 is null, then we return false. So it means that okay, so it means that they are not same. Also, along with this, if the values are not same, let's say the values of the node itself is not same, so t1 dot val is not equal to t2 dot val, then we can just simply return false at this point, right? There is no point of moving forward. Then we can do two things over here. One is like we can say that whether if we don't swap it, then are they equal. So the first case is like we can just simply compare them as it is. So we say that recursive, we're just gonna call it as it is. So recursive t1 dot left, so this is same as t1 dot left and t2 dot left, they are same. And again I'm gonna copy it, um, I'm just copy it with this t2 t1 dot right and t2 dot right. So either these are same, or like, so either this is true, so this is one aspect, like there is no flip, assuming that there was no flip, either this is true or the flip part is true, which is basically, let's say they have been flipped. So in that case I'll be comparing the left with the right and right with the left. That's it, and we can just simply return it. So it's basically a four-liner code. One comparison we are making just with the with by assuming that no flip is there, so either this returns true, and we are doing it at every single node. So um, and this doesn't increase the complexity. So if you're thinking that it increases the time complexity, no, it does not. The Can someone tell me the reason why the time complexity is still O of n, although we are making like we are making twice, so it kind of feels like O of n square, but it's O of n. Can someone tell me like why the time complexity is O of n in this? Yes, that's the reason. So if you compare, if you do, so either the swap one will be true. So you will not, both of them will not be true at the same moment, right? And it's given that all the nodes are unique. So so essentially only one of them will go through that. Let's say if you're comparing without the flip part, so when you compare 2 and 2 with 3, here 2 and 3 will not match, so the first one will not even go into the depth. It will just return false from here, from the very first statement. When you go to the left, and here also you go to the left and right. But then when you go to the left for this, and you go to the right for the second, so it means that you're comparing the left branch of first and the right branch of second, so then it will be a match. So so basically we are filtering out one of the branches at the very beginning itself. It will not execute completely for all the branches. That's the reason, entire reason for it. Is there a way that we can do it iteratively? Is there an approach that we could do it iteratively instead of using recursively? So what you can do is we can do a iterative traversal using stack. I think we discussed that idea before as well. So we'll be checking the values that if left sides are same, let's say if left of this branch is same as the left of this branch, then we push the left side, the left two nodes onto the stack together as a pair. Otherwise we push the opposite ones onto the stack. So we push the left one for this and the right one for this. The way to do that, so what we can do is we can create an iterative method. In the iterative approach, we can take a stack. So let's say in the stack, let's say if I can create a pair of tree node comma tree node. So this is the pair that I can take. Now the next step is that we can push the root itself onto this. So stack dot push new pair, and over here we can say that t1 comma t2, right? If stack is not empty, till the time it is not empty, we'll just keep on like popping the pair. So let's say this pair object we pop, and then we check that whether this pair, let's call it a p. So stack dot pop, and then we check whether both the values are same. So we say that get key and get value. Okay, so we have got both the nodes now, n1 and n2. Now we can just copy paste this line over here. Let's call it t1 and t2 so that we can just, the code remains same. So if t1 is equal to null and t2 is equal to null, return true. If basically we don't need to return then. In case if we can just simply continue at that point. There might be some other elements in the stack, but if in case one of them is null or the values are not matching, we can just simply return false at that point in time. Then before pushing in the children, what we can do is we can check that if t1 dot okay, the idea is that we will not put, will only push the matching ones into the stack. So the better part is that we could wrap it inside a function, just let's say boolean check util. So check nodes equality, something like this. And over here we can just pass over here tree node t1 and t2, and then we can just simply copy this entire stuff that we were doing here. So we could just um, return true and then return false. Okay, at the end we need to return true. So um so this can be a utility method that we could expose, and we could, instead of, we can just call it over here, if check nodes equality t1 t2 is not true, then return false. So that is the very first thing that we could do. Now we can call this utility. We can say that if left is same as this, okay, right is same as, basically we are directly comparing the left nodes and the right nodes at this point. So if right is same as the right node, in that case we will end up pushing. If this is the case, then we can safely push stack dot push new pair, and then over here we can push t1 dot left comma t2 dot left, and then we can also push the right, and the pair of the right as well, t1 dot right and t2 dot right. And then in the else part, we can just push the reverse, t2 dot left and t1 dot left and t2 dot right. Okay, and so this is basically about it. And then at the very end, if nothing returns false, then we can return true at the end. So this can be iterative way of doing the same thing. We can maybe check it out. So I think, okay, this is the recursive code that's running. There will be some things, line number 17 and line number 29 typo. Change the n1 and n2 for above, it's be better, n1 and n2. Now we can call it n1 n2 here. Oh, I changed it to p1. Okay, so I think right now it's just doing the recursive part, but let's try out the iterative as well. So if we go ahead with the iterative, both the nodes are null, then there is nothing more to push, right? So if t1 is null, if t1 is null or I think we have already checked the equality. So if one of them is null, then second one will also null. Then we can just simply continue at this point. We don't really need to push anything further. So that is like creating the issue, right? So that was a problem. We can submit. So this submits, right? So basically we have discussed both the iterative version of it and the recursive version of it. I hope this part is clear.